guys, how are we going? I'm just sitting back having a wondering. Does Pythagoras Theorem actually work? Now, I'm sure a few of you would have used Pythagoras Theorem before, and I know a few of you have used it before, and a few of you are all over it. However, there's some of you who may have forgotten how to use it or haven't used it yet. So what I'm going to do is unpack Pythagoras Theorem and let you know how to use it and what it actually is. So first of all, when do we use Pythagoras Theorem? So Pythagoras Theorem is used when we're dealing with right-angled triangles. There's a beautiful right-angled triangle right there. So we've got our triangle there, and we can label the sides. So the side opposite the right angle is going to be the longest side, and we call that the hypotenuse. So this is the hypotenuse, and for this case we're going to label that C. So the hypotenuse there is C. We're then going to label the other two sides A and B. A and B. Now, Pythagoras Theorem states that C squared, being the hypotenuse, equals A squared plus B squared. So that is our Pythagoras Theorem. What I'm going to do now is put some numbers into this triangle, and we're going to unpack this formula and see how we actually use the formula. So, C squared, we're going to label that as X. That's, correction, C, it's not squared yet. C just here, we're going to label that as X. That's what we're looking for, that's what we want to find out. A, we're going to have as 5 centimetres. And B down here is going to be 12 centimetres. So, let's substitute these values into our formula. So, instead of C squared, we have X squared. Instead of A squared, we have 5 squared plus, instead of B squared, we have 12 squared. So, let's go through and we'll start doing the maths for this. So, X squared will stay the same, equals 5 squared, 5 times 5 is 25, plus 12 squared, 12 times 12, 144. Alrighty, so now do the next step. That is doing the addition just here. So X squared equals 25 plus 144, which gives us 169. Now what we need to do is get X squared by itself. So what we do here is to unsquare a number, we do the inverse of squaring a number. So the inverse of squaring a number. Can anyone tell me what operation we're going to be doing? What are we going to be doing here? Have a bit of a think. Instead of squaring, we're going to utilise the square root. So if we square root both of these sides, instead of X squared, we end up with X by itself. The square root of 169, what do you multiply by itself to get 169? That would be 13. 13 times 13 is 169. You can double check your answer there. Therefore, X, it's meant to be an X, equals 13, and what's our unit? Centimetres. Make sure you include centimetres. Going to circle our final answer there as well, so it's clear. And as you can see, we've worked through all of these steps here. Fantastic. What about if our triangle, if it isn't C that we're trying to work out, but it's one of the other sides? So let me draw up another triangle. So, here's another right angled triangle. This time, our longest side there is 6 centimetres, and we're going to have 3 centimetres just here. And this one here is the unknown, that is x. Alrighty, so first we need to go through and we need to label them A, B and C. So, that one is C, you remember, and you've got B down here and A there. So we're going to write out our first step of our formula, being C squared equals A squared plus B squared. Now we can substitute our values in. So C squared, 6 squared equals, what's A squared? It's 3. A instead of squared there. We won't need that because it won't make any more mistakes. We'll be fine. 3 squared plus our unknown here, which is x squared. So now we're going to go through and do the maths. 6 squared, what's 6 times 6? Exactly 36 equals 3 squared, 3 times 3, 9 plus x squared. Fantastic. And now what we want to do is get this x by itself. So we've got a positive 9 over here. So if we take 9 away from this side, we need to do it to this side as well. So 36 take away 9, 27 equals x squared. So now what we need to do is to get x squared by itself, we need to do the inverse of squaring a number, which is the square root. So the square root of 27 is 5.2, I believe. Correct me if I'm wrong there. 5.2 equals x. Then we'll finish off. Therefore, x equals 5.2 centimetres. And circle it there. So that is 2 examples of how you may use the Pythagoras Theorem